This is part 2 of lesson 4.2. Now we're going to do some examples of solving variables where we have multiplication and division this time. So let's start with example A over here. We have 3y is equal to 18. Our y is being multiplied by 3. That's what that means. When you put a coefficient or a number in the front, it means multiplication. So the inverse or the opposite of multiplying, in other words, unmultiplying, is dividing. Dividing. So if I want to undivide or unmultiply, do the opposite of multiplying, I just divide. So what I do is I'll take my 3y, divide that by 3. When I put a line like that, what that means is division. And since I divided by 3 on the left side, I need to divide by 3 on the right side as well. So 18 divided by 3. Now that I have 3 in the numerator on top and in the denominator at the bottom, they cancel out. That's because 3 over 3 is 1. So it's like having 1y, but I don't have to put 1 if I have 1, so I just put y is equal to 18 over 3, 18 divided by 3, which is 6. In example B, I have 5x is equal to 10, so my x is being multiplied by 5, so the opposite of a multiplication is division. So I can do 5x over 5, so 5x divided by 5 is equal to 10. I have to divide by 5 on that right side as well, since I did it on the left side. I can cancel out the 5's. 5 over 5 cancels out. Now I have x is equal to 10 over 5, which is 2. Next, we have negative v is equal to 9. So when we look at negative v here, you have to be careful. That negative v really means negative 1v. It means your v is being multiplied by negative 1. But we don't have to write the 1. Remember, it's implied. It means we know that means we know it's there. I'm just going to rewrite it out so you don't get confused, just show you what's happening here. So negative 1v is equal to 9. To find what v is, I have to do the opposite of that multiplication, so I divide. So negative 1v divided by negative 1. And then I do 9 divided by negative 1 as well. Negative 1 over negative 1, that cancels out. So we get v is equal to 9 over negative 1. Remember, when you do a positive number divided by a negative number, that becomes a negative number. So we have negative 9. Now we'll do example D. In example D, you'll notice that we don't have a multiplication. We now have a division. That line there means division. So we need to undivide, which means we need to multiply. So to do that, I look at my denominator. I look at what I'm dividing the variable by, and that happens to be 3 here. And I have to multiply everything by 3. So I would do 3 multiplied by n over 3 is equal to negative 4 multiplied by 3. When I put two brackets like that, side by side, nothing in between, it means multiplication. Now, on the left side, the 3 will be in the numerator. So since I have 3 in the numerator and 3 in the denominator, that cancels the 3's out. They're 1. So I get n is equal to negative 4 times 3, which is negative 12. And so we did some examples where we had to do inverse operations for multiplication and division. We've also done examples in part 1 of this video where we had to do inverse operations for addition and subtraction. Now what we're going to do is we're going to do some examples where we combine the two. So let's start over here with example A. I'm going to use this table to show you the planning I'm doing for the first two examples. And then afterwards I'm going to do the examples C and D without the tables, since you'll have the idea in your mind already. So if we look at A over here, we have negative 3x plus 12 is equal to 15. There's two things happening to our variable. First of all, there's a multiplication happening to it. It's being multiplied by negative 3. Secondly, there's an addition happening to it. We're adding 12 to it. So we're multiplying and we're adding. So we have to think about what the opposites are. How do we unmultiply? How do we unadd? So the inverse operations of multiplication we know is division. So we know we have to divide by -3. And the inverse operation of addition is subtraction. So we know we have to take away 12, so -12. Now when it comes to doing multiple inverse operations, we have to remember that BEDMAS has to be done in an inverse way as well. So normally we do BEDMAS, but now when we're solving for a variable, we do SAMDEB. So that means we need to do our subtraction first, and then we need to do our division at the end. So I'm going to start that out over here. We have -3x plus 12. The opposite of plus 12 is -12. Is equal to 15 minus 12. If I do minus 12 on the left side, I need to do it on the right side as well. Plus 12 minus 12 is 0. So now I have minus 3x is equal to 15 minus 12, which is 3. And now I can do my division. So minus 3x divided by minus 3 is equal to 3 divided by minus 3 as well. I can cross out the -3 because they're 1. And so what I get now is x is equal to 3 divided by -3, which is -1. We'll do example B in a similar way using the table. If you want to try it yourself first, you should. Pause the video and then try it and then check your answer after. So the order of operations, let's take a look. So x, what's happening here? Well, x is being divided by 2. So there's a division happening. We can see that x is being divided by 2 because there's x line and then 2. We can see that there's also an addition happening. 5 is being added to x. So we need to undivide and unsubtract. So that means we need to do a multiplication. We need to multiply by 2. And we need to do a subtraction. We need to take away 5. Remember that normally multiplication comes before subtraction, but now we do the opposite order. So we do a subtraction first. And then our multiplication after. So it would look something like this. We'd have x over 2 plus 5. The opposite of plus 5 is minus 5 is equal to 11. I have to do minus 5 on the right side as well to keep that equation true. 5 minus 5 is 0, so I have x over 2 is equal to 11. Make sure those equal signs line up. 11 minus 5, which is 6. Now I do a multiplication because my x is being divided by 2, so I multiply by 2. So I write 2 x over 2 is equal to 6. I multiply by 2 on this side as well. On the left side I have 2 in the numerator and 2 in the denominator. So the 2's cancel each other out and we get x is equal to 6 times 2, which is 12. So now you can try examples C and D. Try them yourself first and then verify your work in video. So for example C, I'm going to start off with my addition subtraction here. So minus 2x plus 4. To take away the 4, I have to subtract 4. And then I do 14. I also subtract 4 on the right side. 4 minus 4 is 0, so I have minus 2x is equal to 14 minus 4, which is 10. My x is still being multiplied here. So I divide by negative 2 on that side and the left side, and divide by negative 2 on the right side as well. The negatives 2 cancel out because they equal to 1. So I'm left with x is equal to 10 divided by negative 2, which is negative 5. And now I'll do example D. Same idea. X over 2 minus 10. The opposite of a minus 10 of a subtraction is addition, so plus 10 is equal to 3 plus 10. Minus 10 plus 10 is 0, so I'm left with x over 2, meaning x divided by 2, is equal to 3 plus 10, which is 13. My x is being divided by 2, so the inverse operation is a multiplication. So I do 2 times x over 2 is equal to 13 times 2. Two in the numerator and denominator cancel out, and so we get x is equal to 26, which is 13 times 2. So what we've just seen here are examples where we solve for variables when there was a combination of addition, subtraction, multiplication, division, inverse operations to do. Our last example is going to be to check if the solution is correct. How do we check to make sure we are on the right track, we solve for the proper x value? So when we do that, there's a process that you follow called left side, right side. And so what we do is we evaluate both sides of the equation. And if both sides are the same, then the solution is correct. So let me explain what I mean by that. So I'll make a little table called the left side, right side table. Left side over here, right side over here. Right side, the left side is 2x plus 5. And the right side is 20. And I'm going to take my solution, which is x is equal to 5, and put it into the variable to see if I end up with 20. So I'll do 2, replace the x by 5 here, plus 5. And I'll just remember to put 20 here because that's what the right side is supposed to be equal to. Then I get 2 times 5 is 10, plus 5 is equal to 20. Okay. Then 10 plus 5, I get 15. And our right side is supposed to be 20. So what this means is that x equals 5 is not the solution, because our left side does not equal our right side. In other words, what we just did here is we just took this x, put it in here, and we checked to see if it equals a 20 when we do that. 2 times 5 is 10, plus 5 is 15. That's not the correct solution. So left side is not equal to right side, which means that x is equal to 5 is not the solution. You can try to find the solution, and then you can check your work using the left side, right side table to see if your solution was actually